Academy Foundation presents Creating Matter 101. Please let us know if you prefer this or the live voice. Conservation of mass does not apply in the quantum realm. Here, mass is created and destroyed by the way energy comes into focus and defines its spaces. As of Planck and Einstein, light and matter were two ways to express the same total energy. That energy is conserved, which raised the natural question, how do we create matter? Dr. Manhattan of The Watchmen is a guy who can really suck the energy out of a room. His power is creation. That starts with focus, where diverse available energy flows into an interference event that mixes the cycles into a period of temporal scale. That final scaling completes the event instant of material creation when spaces become exclusively distinct. The focus topic is often classified in a broad brush stroke with color confinement. It is the most basic form of strong fusion, creating the instant of material identity, hence instantiation. These are several ways to establish focus, so even instantiation is a really broad brush stroke. Creating matter is like cooking. Eggs over easy can't be done on a barbecue grill, but once the eggs are cooked they are solid and can be put on the barbecue. Slamming doors with a souffle will cause it to collapse and lose that fluffy texture. Turning the temperature up braises and burns. It doesn't bake or cook faster. And just throwing the ingredients together doesn't mix them into a recognizable form. To understand focus we need to frame scaling as Bose did. Einstein initially packaged infinite possible configurations of light energy into photons. Bose then treated photons as a gas. This is not a literal interpretation of energy. It is a way to visualize a complex field. A field defines all its points. By treating light as a gas, you can now see the concept of brightness in more tangible terms. Brightness is a superficial scaling. The energy of light is a function of its frequency, the number of cycle periods in a second. The magnitude of that energy is its unit scale. The details of bright things come into focus quickly. As you increase distance to the source, the distribution of energy over the same surface of space diminishes. The exposure takes twice as long to bring 4e into the same focus as 8e. This is diverging out of focus. Protons are degenerate densities, making them ideal energy in focus. Accelerators by definition compel matter out of focus into particle beams spread around the entire period of the magnetically shaped track. The LHC, as an example, accelerates batches of 120 billion protons into 30 or 40 million collisions per second. All mixing is incidental to the sequence and consistency of the collisions. It isn't cycled to draw it back into focus. Celestials with active cores are dense enough that their path through free space creates neutrinos. Stars in particular are dense enough to create a large potential well to trap and mix the raw standing energy of free space into neutrinos. It is then dense enough to cycle, remix, and slowly bake them into hadrons, and hadrons into complex nuclides. The potential well brings energy into focus. Every identity consists of a bicomplex of radiant emission value and absorption values. The absorption value is the defining instant, an imaginary axis of temporal scale. For light this is a narrow distribution in time diverging into an inversely wide space. Matter conversely projects its instant as a wide distribution in time funneling into a narrow space. This funneling is the potential well around the object. Energy gets funneled into the available spaces, like the bands of gluons and charged leptons. These bands occur in pairs called flux tubes. We first observed this with electrons emitting photons. We call this type of production meiosis because it is a reduced form of the parent and the parent didn't lose its identity. Mitosis is pair production at the expense of the parent, like gluons and weak bosons. The least familiar form of focus is a potential well created by a quadrupole of overlapping magnetic fields. In one stage of the galactic life cycle, the singularity emits bursts or streams of energy. Much of that energy gets recycled back into the process and refocused by the local magnetic fields. This allows for a slower process of streaming into an identity cycle. It is also potentially reproducible, perhaps a future generation of accelerators that will instead be called decelerators because they will decelerate the effect of light into confined material identities. Now that we have focus, we need energy to be put into focus. What exactly is energy? Work and heat are among many specific spatial applications. The typical energy definition also mentions transference. Only dynamic and available energy can transfer. Energy is only dynamic in bicomplex form. Conservation specifically states that energy is never lost, it only transforms. Let us elaborate. The total absorption and emission in the universe are proportionally constant. Emission values belong to events like light, free space, and matter. They give magnitude to space. Absorption values collectively belong to the whole universe. They provide the scale of space. Combined into a pattern like this, they become dynamic and propagate. Matter like a proton is standing energy, but it still needs to be forged from dynamic energy. We typically think of energy in three forms, as light, matter, and kinetically as the motion of matter. The two most readily available forms of energy are light and the CMB of free space. The simplest mixing is crossing two streams, which causes phase modulation. That is basically what particle accelerators ultimately do, because they do nothing to sustain the focus. If they did sustain focus, then the next natural mixing would be a fluid-like dynamic, likely compelled by fluctuations in dilation and mechanical turbulence. Mixing in nature will likely involve a combination of mechanical turbulence, dilation fluctuations, and opportunistic fluid-like field dynamics. Neutrinos, as an example, form by free space dilating into focus by the mechanical passage of a celestial object that applies its complex thermodynamic field conditions. The mixing angle by itself combines two axes of one generation into a bicomplex axis of another generation. These triangles have emission and absorption axes of one generation that combine into the triangles being the second generation. If we further interact these two triangles, then a CKM matrix is applied to account for that evolution in change logic. It is formally described as rotating between weak and mass eigenstate perspectives. The angular axis rotates into the linear axis to form an interactive bicomplex. The magnetic constants are angular axis projections. Planck's reduced spin constant is the bicomplex. These three sets of constants never change. The linear axis pays the price by adapting to the mixing angle. This is a fairly small but significant and annoying variance. Take the case of nuclide density. It turns out that all nuclides do not have the same density. The ideal is degenerate density that definitely applies to protons and neutrons. The numeric value derives exclusively from ideal constants. The units apply those constants into a pressure change scale context. Each hadron has this density, so we can simply divide the total hadron mass by the density to find their collective achronal volume. That means the points are not divisible into a temporal distribution. They all occur in the same temporal position. The cube root of that volume divided by 2 gives a hyperbolic metric of a circular value. Removing those qualities with constants leaves the charge radius. The case of gold clearly shows a discrepancy. The structure has chronal differences, time separating or otherwise distributing the parts, that dramatically increases the mixing angle and modifies G. Everything is fine while the energy is accumulating and under the direct regulation of the parent. The final step is where an identity defines a local space for itself. That independence immediately limits how and to what degree it can share its spaces. The quantum form of Pauli exclusion is more complicated than a handful of variables. Like most of us, Max Planck at some point had the bright idea of playing the formulas and constants to find natural units known as quanta. It turns out that our little mixing problem at least partly answered the question of what should be treated as quanta. And it wasn't specifically these constants. We can now start with the pixelation of free space if we want. The explanation probably starts here and the next 1.2 billion light-years of depth in that field. But really we can start with somewhere closer to familiar. While electrons and protons are complex matter, they are also the ideal and smallest forms of degenerate pressure and degenerate density. They are the universal benchmarks, the basic quanta to set all units of measure by. Everything else in the universe quantizes relative to them and the spacetime constants, accommodating of course for the mixing angle. Spacetime constants come in three categories. They are either values being given, how the value is being taken, or the bicomplex relationship of this process. Within the first two categories are linear, angular, and projection differences. Magnetic fields are projections directing excess value around the object. They are nature's way to force variables. Permeability is a temporal function of energy, whereas permittivity is atemporal. Generally we assume permeability is the emission because it has the temporal element. In that case, permittivity is how the space responds to that emission. It can also go the other way where an atemporal condition mixes into a permeation. Their product is a spacetime composite appearing as c². The energy permeating may not be the right polarization for the receiving space, or one or both may be unpolarized. This and bandwidth will lead to significant differences between the amount of available energy going in versus what applies. To alleviate confusion, the absorption axis is relabeled D. This sets the limit to the amount of value that can be applied. So long as the added value is less than the absorption value, then the parent is defining that space. Once the value fills, there are now two functions trying to define the same space the same way, triggering exclusion. Exclusion is a temporal violation, so it applies in the instant between with confusing consequences like entanglement. I wouldn't be the least surprised if all those light blue shards are the same lepton sharing the same position in time despite a counterintuitive distribution in space. The size of that instant is the energy frequency consisting of the bicomplex scalar value relative to the time displaced to contain that value. That leaves us with the inconvenient case of the quadrupole focus achieving the proton and electron minimum in free space. While we haven't computed the exact Y for these quantizations, Lyman-alpha processes locally and as galactic processes make a compelling argument. Contrary to popular opinion, the universe is not compelled to produce matter exactly one way. Even when it mass produces an abundant diversity of leptons, neutrons, and protons, without extenuating circumstances to maintain such chaos, they all quickly simplify to just electrons and protons. My apologies to the audience members hoping to hear that willpower could play any role in the creation of matter. It can, but it requires a lot of extra equipment, know-how, and willingness to cheat off nature's examples. Remember to like and subscribe. Thank you.